Hi everyone, today we're going to finish 10.3 day 3, and that's going to be on continuing the graphing cube root functions, but we're going to be actually modeling real world situations with cube root functions today, so that way you can see how they're applied. Let's take a look at the first example here. The velocity of a 1400 kilogram car at the end of a 400-meter run is modeled by this function here. And V stands for the velocity in kilometers, P for the horsepower in the engine. So let's write down the equation here because it's not very clear. It is actually 15.2 and then cube root of P for the equation. So let's use that to obtain our values right here. So it's 15.2 cube root of 0, which just gives us 0 for the first one. And then if we continue this, it would be cube root of 60 and approximately should give you 59.5. And then continuing the same pattern, you should have 75.0 and 85.8. So those are the values. And notice that we're only using positive numbers here because this is a real world situation when we're only working with the positive values. So even though if we know that for a cube root function, it should look like the shape of an S, but we're only going to have the positive side, which is like the first half of it. So when we graph it, it should be 0, 0, and then 60 is almost right here, almost 60 again. And then 120 is going to be 75, which is like right here. And then at 180, it will be 85.8, like right there. So if we connect this, we will have the positive side of the graph, which kind of looks almost like the square root. But again, know that we are only working with the positive values in the real world situation. Okay, so that's why the graph is like that. Next part, we're going to be calculating the average rate of change just like we did with the square root function, but this one they want it over equal intervals. So that means we don't want just the first and the last this time. We're going to want every interval. So we're going to be actually looking for this one, and this one. So we have 3 rate of change this time, and we're going to show the work here. So hopefully you have your values to work with in front of you because you can't see it anymore. So we got R1, the rate of change is 59.5 minus 0 over 60 minus 0, which gives us 0.99. And next one, R2, should give us 75 minus 59.5 over, what is this, 120 minus 60, and that should be 0.26. And then R3 is going to be 85.8 minus 75 divided by 180 minus 120, which is approximately 0.18. So D says what happens to the rate of change as the value P increases. So as you see that as we move down the intervals, the average rate of change is actually decreasing, so it's going down. And that's what is happening. And find the velocity when P is 100. So using the same equation that was given, 15.2 cube root of P, well, if we substitute the 100 horsepower into for the P, we should have approximately 70.6 kilometers per hour would be the velocity for the specific given horsepower. And that is the end of the problem. I'm going to take a look at one more. The fetch is the length of water over which the wind is blowing in a certain direction. And here's the function given relating to the speed of the wind, S, and the fetch. So here is the equation, 7.1 cube root of F. The same way, we're going to substitute F equals 20 in the first one, and we should have the answer of 19.3. So verify with your calculator, please, to make sure that you're getting that answer. And we're going to continue the pattern, and you should have 30.6 for the second one, 36.9 for the third one, and 41.5 for the last one. And graphing this would give us 20, 19.3, and then at 80 is going to be 30.6. At 140 is going to be 36.9, and then at 200 it's going to be 41.5. So if we continue and we draw this curve, it should be a round, smooth, round curve. Again, this is, even though it says cuboid function, we're only using the first part of it because we are dealing with positive values in the real world situation. So that's why we're only looking at half the graph only. And let's answer the next question. Again, calculate the average. So again, we have three intervals here, 1, 2, 3, that we're going to be calculating. So let's go ahead and show the work for R1. It's 30.6 minus 19.3 over 60, which is actually 80 minus 20. That's how you get 60. And you get 0.19. And R2 is going to be 36.9 minus 30.6 over 140 minus 80. That's also 60. And you get approximately 0.11. And the third one, we have 41.5 minus 36.9 divided by 200 minus 140, which is also 60, 0.08. And again, if you take a look at the different average of change as we go down the intervals, is that it is decreasing. So it is slowing down again. And so the last problem says, find the speed of the wind when F equals 64. So again, we have S of 64 that we're looking for, which is according to the equation 7.1 cube root of 64. Substituting 64 in, and you should have approximately 28.4 kilometers per hour for the speed. And that is the end of the problem. In fact, that is the end of the lesson for all of Module 10. So go ahead and get started with your homework by logging into Google Classroom. Have a nice day.